Hi, hello, welcome to the class. Heat and temperature, part 2. Yes, yesterday in the last session we discussed what is heat, how it is transferred, what are the units of heat, and the three modes of the heat transfer. So, once we'll revise the modes and we'll move to the applications. Yes, modes of heat transfer. Modes of heat transfer. So there are three modes of heat transfers. One is conduction, convection, radiation. Right? Already yesterday in the last class we discussed what is conduction, what is convection, what is radiation. Right? So what is conduction? Transfer of the process of transfer of heat without movement of molecules, without movement of molecules, we call conduction, and there should be a direct contact between the objects. Convection, with the process of transfer of heat energy with the movement of molecules, we call it as convection. Radiation, the process of transfer of heat without any medium, we call it as radiation. Among these three modes of heat transfer, conduction is slowest method. The transfer of heat is slow through conduction process and very fast through radiation. Fast or fastest. So what is the fastest mode of heat of transfer? Radiation. Which is the slowest mode of transfer of heat? Conduction. Now we will look into the application of conduction, convection, radiation. We are having three modes of transfer of energy. Obviously we are using, where we are using in your daily applications, where you are using this knowledge, applying the knowledge in your daily basis. So now we will study the applications. Right? The first is where we are applying the conduction mode of heat transfer in your daily basis. Think where you are using. Daily you will take the bath. Yes. So the heater, how water will be heated? By the direct contact. Yes. The conduction is used in water heaters. Next, cooking. For cooking food, which mode of transfer of heat energy is happening? Yes, conduction. Cooking food. ironing of clothes or ironing of clothes. Ironing of clothes. These are the few applications of the conduction. Next is convection. Convection. In olden days, we had ventilators and windows. Yes, now we are having windows. We don't have ventilators. But before, in a room, we had ventilators and windows. What is the difference between the windows and the ventilators? Position. Ventilators are located at the higher level of the room and windows are located at the lower level of the room. Why? The cool breeze will have more weight and the hot air will have less weight. So whatever the cool air from the surroundings, it will be enter into the room through windows. Due to the movement of these cold wave into the room, whatever the hot air that present in the room will obviously move up and escape from the ventilators, right? So this is the first application of the convection. Windows and ventilators. Why always ventilators are located at the top, windows are located at the bottom? That is the reason. Cool breeze or cool air will move and this cool air will push the hot air up because of less weight. The hot air lighter, that's why it will move up and it will escape from the room from the ventilators. This will create a circulation of air in the room. Circulation of air in the room. Nowadays we have ACs. Why ACs are fitted at the top? Same reason. The hot air will be lighter, it will move up, and the cold air will have weight heavier, they will move down. So that's why ACs are fitted and fans are fitted. ACs or fans are fitted at top level of the room. These are the applications of the convection. Even we have another, we can see the convection, ocean currents, climatic patterns, that is weather patterns. You know we had a weather patterns, summer, winter, spring, autumn, this rainy season. How? Because of this convection process. So weather, instead of seasons, you can write patterns. Weather patterns. Right? Ocean currents. Ocean currents. You can see the convection process. Have you heard that the coastal areas will be warmer at the winter, cooler at summer region when compared to the remaining regions? What may be the reason? See here, at coastal areas, so what are the coastal areas? Yes, the areas which are at the sea, border of the sea. So think the coastal area. Obviously, what is this? This may be ocean, this may be sea, water body. The land which is next to the sea, we call it as coastal areas. And this is the land. This is land. During morning, due to solar radiation, whatever the air molecules that are present above the earth and above the water will heat up. But whatever the air above the land will heat fast when compared to the sea. So air above the land will heat up fast when compared to the land. Right? Now, whatever the heat up air due to of lighter weight, they will move up, and the cold breeze from the sea, will move. Right? So whatever the cool breeze surrounding will occupy the space. Due to movement of this cool breeze, whatever the heat waves will move up due to of lighter weight. This we call it as sea breeze. What is this? Sea breeze. So sea breeze will be during morning. So the cool air from the sea, it will move towards the land. And whatever the hot air in the land, it will move up. And there will be a circulation of air. So this is the sea breeze. During night time, right? Again there is a sea. There is a land. The air above the land will decrease its temperature fast. So air will decrease temperature faster when compared to on the air above the sea. Now what happened? This cool air will move towards the sea, and whatever the hot air above the sea will move up, and this we call it as land breeze. If the breeze is coming from land towards sea, that is land breeze. If the breeze is coming from sea towards the land, then it is called sea breeze, right? Sea breeze is during morning, land breeze is during night time, because air above the land will heat up fast as well as it will cool fast. So the movement, the circulation of hot and cold air, we call it as land breeze and sea breeze. Okay, do you understand now? So these are the applications of convection, transfer of heat examples. Now radiation. So radiation without any medium, process of transfer of heat without any medium, right? Here, have you seen the thermoflask? Yes. If you see that, the thermoflask, sorry. What is this? Thermoflask. If you see thermoflask, you can see the two containers. One will be the inner, other will be the outer. Between the outer and inner wall, we will have a gap. That gap may be filled with this gap. That may be filled with insulators. What is the meaning of insulator? We will study. Or that may left vacuum. That means there means no even air at all. Even vacuum is almost like an insulator. Insulators, the substance which do not allow heat to transfer through them. Those are called insulators. If this gap is filled with insulators, what happens? Whatever the thing I poured hot milk in it. This will be contact with the inner wall of the vessel, and this heat is not transferred here. So we can minimize the loss of heat energy by conduction process. And if you see that, we will have a cap. That cap may be of, even it may be of rubber or plastic, right? Why? This cap will reduce the loss of heat through convection, right? And this vacuum will reduce the heat, it will not allow the loss of heat energy through radiation, right? The thermoflask is used to decrease the loss of heat energy. So that's why whatever the thing we are dropping into the flask will remain its temperature for longer time. Even hot boxes, the same concept. That cap may be filled with thermocol or any insulator, or it is kept vacuum. Right? Now, here the radiation, one of the application is thermoflask. Thermoflask is application of all three: conduction, convection and radiation, but not to increase the heat transfer, to decrease the heat transfer, to minimize the loss of heat energy. And the radiation, best example is solar energy. Okay? Whatever the light will also carry the heat energy. That is called, process is radiation. With or without medium, it will transfer heat from the sun to the earth. So these are the modes of transfer of heat energy, and these are the applications. Which is the fastest mode of heat transfer? Radiation. Which is the slowest? Conduction. Right? Now we'll move to the conductors and insulators. When we are discussing thermoflask, I said that the gap between the inner wall and the outer wall is filled with an insulator or a vacuum. You know vacuum? Vacuum is a medium which doesn't have any matter, any particle, right? Vacuum, right? Medium which don't have any matter, that we call vacuum. Now, insulators. All the substances will not allow the heat to transfer through them. Some will allow, some will not allow. Based on that property, the substances are divided into two types. conductors, insulators, conductors and insulator, based on the property whether the substance will allow the heat energy to transfer or not. Conductors means the substance or the substances which allow heat energy to transfer through substances which allow heat energy to transfer through it. We call it as conductors. Insulators, opposite. Substances which do not allow heat energy to transfer through it or through them, through it. We call it as insulators. Right? Examples of conductor: aluminium, or most of your cooking vessels are made up of aluminium, steel. Why? They are good conductors of heat. Steel, aluminium, copper, brass, silver. Why we wear silver? To reduce the heat. Gold. Okay. So most, I am not saying all metals, most of the metals are conductors of heat. Conductors of heat energy. Even in heat energy, transferring of heat, conductors may be good conductors or bad conductors. Sorry, poor conductors. Poor means, yes, they allow heat energy, but they'll allow very less. Right? Even conductors are two types. Good conductors and poor conductors. That means they'll allow the energy, heat energy, but the good conductors will allow fast, the poor conductors will allow very less. But when we speak about the insulators, they will not allow the heat energy to pass through it. Think, what are the examples of the insulators? Plastic. Have you seen your cooking vessels? Their handles are made up of plastic. Why? Because they are insulators of the heat. Rubber. Next. Yes, wood. Right? Glass. These are the insulators. They will not allow the heat energy to transfer through them. Right? So, good conductors and bad conductors. Based on our applications, we will use both. Yes, see your cooking vessels. We will use steel, but handle is made up of plastic. In flask, yes, glass is, most of the inner wall is made up of glass and the outer wall is made up of any steel, plastic or aluminum. They are silver to reduce the radiation. Right? So, these are the conductors and insulators. Right? So, now you understand modes of transfer of heat energy and the substances which allows the heat energy and which the substances which do not allow the heat energy. Now we will move to the next topic, that effects of heat. Yes, up to now we studied what is heat, what are the units of heat, how the heat is transferred, what are the modes of the transfer. But what are the effects of heat? Up to now we studied that yes, the temperature is increased. What? The heat will only increase the temperature. It will not do anything. No. We have few more effects of the heat. Effects. That means what happens to a body when I apply a heat energy, or when the body absorbs heat energy. Effects of heat. The first and foremost important is, yes, if I apply heat, yes, the temperature of the body is changed, increased. If I give heat energy, obviously the temperature is increased. If I remove the heat energy, yes, the temperature is decreased. And second thing is change of state. Change of state of a body. Right? Change of state of body. We know that we have three states of body. What are they? Solids, liquids, and gases. So matter exists in three states: solids, liquids, gases. If I apply heat, think I had ice. If I apply heat energy, the heat absorbed by the ice, it will be converted into water. That is, ice is converted to water. Ice is a solid state, water is a liquid state. If I apply heat energy to water, the water will boil and water will evaporate. Then what is this? Water vapor. Water is converted to water vapor. So liquids are converted to gases. So if I apply heat, the body will change its state from solid to liquid, liquid to gas, sometimes from solid to gas directly. Right? Next, chemical change. What is that? Chemical change. While cooking food, whether the chemical properties of the food will change? Yes, it will change. And if you apply heat, what happens? Sometimes the body will burn, combustion, due to the chemical property will be changed. Whether the chemical property of the paper and the ash are same? No. So the chemical properties also will change. That means there is a chemical change. Next is far most important, fourth one is thermal expansion. That is, if heat is absorbed, the body will expand, that we call expansion. The expansion of a matter due to increase of temperature, that's why we call it as thermal expansion. So now we will study thermal expansion, right? So thermal expansion. So four effects: change in temperature, change of state of body, change of the chemical properties, and body will expand. That expansion we call it as thermal expansion. Expansion of a matter. Expansion of a matter due to the increase of temperature, due to the increase of temperature is called thermal expansion. Yes, body is expanding, but due to increase of temperature, the body is expanding. Thermal temperature expansion, that means the dimension is increasing. So we have three types of thermal expansions: linear expansion, area expansion, area expansion, volume expansion, So how many types of thermal expansions? Three: linear, area, volume. The name itself represents what is this expansion. Linear, length. If the length of the body is increased due to increase of temperature, that we call it as linear expansion. So due to increase of length, so the expansion is, it will increase the length. If the area is expanded, then the expansion is area expansion. If volume is if the volume is expanded, that is volume expansion. The linear expansion we call one-dimensional expansion. That is, in one direction the dimension will expand. Remaining two direction also will expand, but it is very less. That's why we will neglect it. Two-dimensional and three-dimensional. One-dimensional expansion is linear expansion. Two-dimensional expansion is area expansion. Three-dimensional expansion is volume expansion. Area expansion is also called as superficial expansion. Volume expansion is also called as cubical expansion. So area expansion is also called as superficial expansion. Volume expansion is also called as cubical expansion. Right? This is the thermal expansion. Applications of thermal expansion. Have you observed that? Applications. Right? Applications. Have you observed that the telephonic wires, electrical wires, how they will lay? Yes, usually, right? They will be hanging. Why they will hang? Why they are not stretching those cables and the wire straightly? Have you thought why? Because of the called expansion and contraction. The first applications of thermal expansion. Applications of thermal expansion. First one is telephone wires, telephone or electric wires, right? If had been observed, yes, these are the poles. And whatever the wire between the poles will be like sagging. Why? Because in winter season, due to the decrease of the temperature, this wire will contract. Due to the contract, so what happens? So it will contract. So the length is decreased. If I am not allowing this, what happens? The pressure, whatever the force is increased, and it may damage the electric wire and telephone. That's why they allow the, so in winter season they'll contract, they'll allow that contract. Second application is, have you seen railway tracks? Railway tracks, have you observed? Yes, all you have traveled in rail. Have you observed the tracks, how they laid? If you observe these tracks, think that if this is a track, if they want to attach with another rail, they'll provide a gap. Why they'll provide the gap? Because during summer season, due to increase of the temperature, this will expand, even this will expand. To allow that expansion, we will provide that gap. If we are not providing that gap, think. So we are not providing the gap, we laid the rails very nearer to each other. In summer they'll expand, so they'll try to expand like this, but we are not allowing them to expand. So what happens means, if we are not allowing them, they will bend like this, right? If the train travels along it, yes, there is a chance of accidents. That's why we allow this gap to allow the thermal expansion of railway track. And the third application is, have you observed your vehicles? In summer season there will be blast because in your vehicle tire we will fill the air, right? We will fill the air. Air is filled. If the temperature is increased, gases will expand. This will expand like this. They'll create a pressure on the walls of the tire. So that time what happens? They may chance of the blast of the tire. Blast of the. That is the reason, right? So by this, solids will also expand, liquids also expand, even gases will also expand. But solids expand less when compared to the remaining, and gases expand more. Gases expand more and solids expand less, right? So this is your application of thermal expansion. The next class we will discuss temperature, how we will measure the temperature, what are the different meters we use to measure the temperature. Thank you. Bye.